So far in systems of equations, we've done graphing, where we have to, one, be able to graph a line, and then we find the intersection of where those two lines intersect, and that ordered pair is the solution for both the systems.
And doing that right, you start at the y.
Correct. So this one right here, I would start at 7 for the y-intercept. My slope is -1, so I'm going to go down 1 over 1. Okay, same thing here, +1. My slope is 2, so I rise 2, run 1. Okay? All right, so this is the first one. The second one was substitution. All right? And I'm going to let you guys practice this. Find the ordered pair. Solve this system through substitution. So if we let y equal -8x plus 1, then we're going to go ahead and take whatever this y value is, and we're going to plug it in here for y. So I have -4x minus what y equals, which is -8x plus 1, and that's going to equal -1. So when we solve this, we have -4x plus 8x minus 1 equals -1. And so x would ultimately, in this case, equal 0. So when we come back up here, when we plug 0 in for x, y would equal 1. So my ordered pair, 0, 1.
Well, how does x equal 0?
Because when I add this 1 to both sides, I have I have 4x equals 0. Once I solve this is going to be 0, it doesn't matter what the x is, it's going to be 0. All right, so the last method we're going to do is called elimination. Okay, the idea is that we're going to eliminate one of the variables in order to solve the other one. All right, so the easiest one for this to look like, and this is kind of this is the steps to it. All right. You can always go back to this and look at this in notes if you need to kind of remember what to do. But it's fairly easy. If you notice here, if I give you this system of equations right here, you can see that in this system, I have a positive 2x and a negative 2x. So in this system right here, if I added these two together, my x's are going to cancel. I've now eliminated the x's just by adding the two systems together. And so we have 4y equals 24, y equals 6. All right? Now, what's tricky about elimination is that you will take that y equals 6 and it has to be plugged into one of the original equations. Okay? Not whatever you ultimately will modify some of the equations to be. So I plug this 6 back in for y and x equals 1. Okay? All right, now, let's see. Right. All right, so I want you to solve this by elimination. All right, so we immediately recognize that for my y's, I have a -4 and a +4, so if I add them together, this is going to eliminate. We have 4x equals 8, so x equals 2. Plug this back into either one of the originals, so I'll take the bottom one, so x plus 4y equals -2. So 2 plus 4y equals -2. So 4y equals -4. And so y equals -1. So my solution to -1. Okay? Now, this is a scenario in which my coefficients in front of one of the variables are the same number and different signs. So I can immediately just go ahead and eliminate them. And that's the ultimate goal. The ultimate goal is to do whatever we need to do to the equations to be able to have the same number with different signs. Okay? So, if I come over here and look at this, we're going to go to this one right here. Okay, now I have a situation where I have a 2x plus y equals -5 and a 2x minus 5y equals -13. Well, I have the same number in front of the x's, but I don't have different signs. So take one of the equations and either decide that you're going to go ahead and multiply the entire thing by a negative, or just change the signs to everything. So now I'm going to have negative 2x minus y equals positive 5, and positive 2x minus 5y equals 13. Now I have modified the first equation here in order to be able to get the same coefficients with different signs. So I can eliminate my x's. I have negative 6y equals 18, and so y equals negative 3. Now this is where it becomes important when we talk about the original equations. Because this right here is not an original equation. I modified this beginning equation. So I take this and plug it back into one of the originals, and we have 2x. Instead of the y here, I'll just go ahead and plug in negative 3 for this. And so we have 2x equals negative 2, and x equals negative 1. So my solution, negative 1, negative 3. Good? Okay. All right, now, do we need to do this? We all okay? Okay. So now, you run into situations where I don't have the same numbers in front of the variables. Okay? I have a 1 and a negative 3, a 2, and a positive 1. So I'm going to have to multiply one of the equations by a number in order to be able to eliminate one of the variables. Somebody give me a suggestion. Okay, so I'll multiply the top equation by 3. So we have 3x plus 6y equals 11, and negative 3x plus y equals negative 5.
You don't have to multiply.
I do. I didn't do that. Sorry. Thank you. So we have 7x equals 28. X equals 4. All right. We'll plug this back in for one of the originals. So we have negative 12 plus y equals negative 5. So y equals 7. Okay. Pretty clear? All right. Let's try one. DJ, what did you multiply the equations by?
So I'm gonna multiply the top equation by 2, and then the bottom equation by 5.
Okay. So we multiply the top equation by 2, and the bottom equation by 5. So you're eliminating the x's. So we have negative 10x plus 4y equals 64. And we have 10x plus 15y equals 50. So these eliminate. We have 19y equals 114. So what'd you get?
Wait, oh, you checked the bottom.
Mm-hmm.
I didn't do that.
Tell me what you get then. It's 6. All right, so y equals 6. So I'm going to take this 6 and I'll plug it back either here or here. We'll go ahead and take the bottom one, 2x plus 3 times 6 equals 10. So we have negative 4, positive 6. Okay. Are we good?